Hello and welcome to another update video from Otter Robotics, and this time we'll be showing you our soldering journey.
So, you may have heard in the Easter special that the soldering didn't always go to plan. In fact, the one that we will be doing today will be our 4th attempt. As you can see, we have failed 3 times due to many different issues. For the first attempt, dodgy wiring was the cause of the problem. The second attempt, the spacing was incorrect. And for the final one, the components broke on us.
Before we get started, we need to have a look at some of the tools we're going to be using. The first tool is our soldering iron, of course, because we're doing soldering. This is a very hot piece of metal that's used to melt the soldering wire to solder stuff and components on. This is the soldering board where we're going to be doing the soldering. This is the stand for it. We also have 2 fans to make the fumes go away. Our next component is the drill, which we've made out of Lego Technic. And this is used to create gaps in the lines. The next component is a Sharpie, which we use to mark. And I hope we don't have to use this again. We've also got a knife for removing parts that our drill cannot. We also have a mini hoover, which we use to remove anything that's on the desk. We also have a solder sucker in case things get a bit wrong. We also have wire cutters, soldering wire, pliers to pick any small components up, wire strippers, and that's it.
As you saw earlier, we haven't always had the most success with our soldering, so this time I've made a few more plans to add to the existing 2. Now, the existing 2 we had was this schematic, which is just a circuit diagram to make sure our circuit would work electrically. Then we progressed to this circuit board design. This was made on a program called Fritzing, as you can see. I really like that program actually, it's really good. But here you go, we can see all the components that are going to be on the board and where they're going to be placed. Next, we made this design, which is a very simplified version of what you just saw. And this is one of the new ones, and this just tells us exactly where the components are going. So on here there'll be a component, and then we added in the holes. So this is exactly the same as the one you just saw, but where the red squares are, here we're going to use the drill to make holes. Next, we added on the bridges as well. So where there's those blue squares, we're going to make a line of solder to join the 2 paths together, both electrically and physically. The final thing I did, which was more of a debug than anything else, is a routing design. So this is exactly the same as the thing you just saw, but as you can see, all the colours are joining to different components, and if we have a quick look at this, you can see the key that goes with it. So wherever there's black, there's a ground connection on the board. Wherever there's green, like this, that will be one of the engine outs, and so on and so forth. If you're interested in looking more at these plans, I will put a link in the description to where you can find them.
Now we've seen the plans, now we're going to start drawing on the holes onto the actual circuit board.
we've finished, I'm just going to go through with the multimeter and check all of our brakes, just so if they're not right, it won't blow up the circuitry. Some time has passed since we recorded the first half of this video, but unfortunately this circuit had a few issues. So yeah, we've probed it all out, made sure there's no obvious bugs, and now we're going to test it with the actual software. Let's go with that. So now we just need to get everything plugged into the board and we can get testing. Now we can finally show you how it all works. But first, let's tidy up this wiring a little bit so you can see what's going on a little bit better. So, we've tidied the wires a little bit, but you should be able to see what's going on. Let's set the home point on the servo there and power it up. There's the 6-volt motors. There's the 5-volt Raspberry Pi. You should hear the motors start up, which is because the Pi hasn't issued them any instruction yet. However, when we run the code, they will stop. But let's test the pump in the meantime while the Pi is booting up, because the pump doesn't require the Pi to work. So, if we release these pliers to simulate a leak in the pump, there we go. That should work. And give this a little squeeze to get it started. When the water level reaches the water sensor, which it has done right now, the pump will pump out water from the bowl. Let's fill it up again. There we go. And there you can see the pump is pumping water out of the bowl. Great. And now the water level's gone down. It has stopped again. But in the meantime, let's test out the Pi. So we're going to open a VNC viewer app and open the Raspberry Pi and type in the password. I should mention that I have changed this back to the default password for the purposes of this video. So now the Pi's loaded up, let's open up the code folder. Here we are. And the Abenteuer code. And let's open the script. Like that. In a minute you should be able to hear the motors completely stop, as that's what the code has been written to do. So let's run it. Press 1. And you should hear the motors cut out. There you go. They've cut out. So let's go over to our app, and now the server is running on the Raspberry Pi. Let's open up the app on the tablet and put in the code. It's worth noting that I put it back to its default for the purposes of this video, and let's press on that. Now the control loads up, and in the top corner you can see the battery level indicator, which at the moment doesn't mean much because it's connected up to a mains power supply, but in the boat that will be really useful. Now first let's go and fire up the motors. Here we are. You can see them revving up a bit, and you can also hear them. So let's put it a bit more powerful. There we go. You can hear that. And also the switch at the top of the screen, if we press that, it will reverse the motors. You could just hear that change then. There we go, let's do it again. And put the motors a bit lower. Now let's have a look at the other slider on the screen, and that controls the rudder. So if we move that around, you can see the rudder moving accordingly, like that. And let's put it to the other side. There we go. And now let's have a look at the other switch on the screen, which is this one in the bottom corner, and that will control the headlights. So let's press it. There we go. You can see the headlights come on, and if we press it again, they'll go off. Let's turn the motor down, shall we? Go right down. And let's put the headlights on again, like that. So yeah, that's the circuit board, which is finally now working. After so many attempts and so many fails, we've finally got this part of the boat ready to use. So I count that as quite an achievement.
If you did like this video, please drop a like, subscribe and turn on the notification button.
If you have any other opinions on our video, please leave a comment.
Thank you from all of us at Oz Robotics.
Goodbye.